Okay. So now I am recording, so that part's good. Now, for the problem I just did, does that make sense for you all? Are we okay with that?
Yes.
Just trying to make sure for answering the question for the person who had it. Are they good? Okay, cool. All right, let me go on to the next one, which was... Ooh, I got to do number... hold on one second. I just got a text from my wife. Hold on one second.
Don't worry, just do your stuff. Just keep the door locked.
Sorry, my wife just sent me a text. I guess there was some shooting or something by my house. So, I don't know. Okay.
Really?
I guess. So my wife just goes, make sure that the doors are closed. And number 7. So let me do number 7. I can hear the helicopters. Okay, number 7. Yeah, will do. How trippy would that be? I'm recording with you guys and something like this goes down crazy. Okay, number 7. Okay, so it's asking for the absolute max and min of a closed interval. And so our function is f of x is equal to x cubed minus 27x squared minus 72x plus 8 in this closed interval from 2 to 5. So we need to check the endpoints first. So by plugging in the endpoints into the function, right? I'll do that. 6 times a negative 2 cubed minus 27 negative 2 squared minus 72 times a negative 2 plus 8. I got f of negative 2 to equal a negative 4. Can someone confirm that for me? I just want to make sure that I did it correct. And I got a negative 277 for that one. Oh, I can do that one too, no problem. Okay. If any of you could confirm those two values for me, that I'd really appreciate it. And then the derivative is what I need to do now. And so I'm going to get 18x squared minus 54x minus 72. And I need to check when this is equal to 0. I believe... Does 9 go into 54? I can't remember. Yes, okay. So I can pull out a 9. Is that right? 9 times... Oh, I can pull out something bigger. Oh, 18. Shoot. Okay, so then 18 can be pulled out. I'm going to get x squared minus 18 times 3. And then 4. And so from here, what I'm going to get is x minus 4 and x plus 1. Correct? And I'm going to test these values. So negative 1 and 4. And then plugging in, if I use a negative number, I'm going to get negative times negative, so this will be positive. If I use 0, I'm going to get a negative, and then if I go beyond 4, I should get a positive. Is everyone okay with that?
I had a question. When testing the values, are you testing it on the derivative?
Perfect, yes. This test test in first derivative. Okay?
I have a question.
Sure.
In I think it's chapter, the very last one it was like the one you didn't film, but isn't it, you're supposed to test it on the original f of x?
Okay, so when I'm going to find the value, I plug into the original function. To test intervals of increasing and decrease to determine if it's a maximum or a minimum, I test the derivative. Because the derivative is slopes, correct? So this is telling me the slope is going up. This derivative is telling me it's going down. Here it's telling me it's going up. So what we can see is at 4, it's going to be a min. At -1, it's going to be some sort of max. Right? Now, to determine if it's a local max or min, what we need to do is plug in to the original so we can compare it to the two values that I had for the endpoints. That's where you plug in to get the value. Does that make sense, that subtle difference? Okay, cool. Okay, so then what I need to do now is plugging into the original function. I need to plug in f of -1 and f of 4. So, shoot. Going back to my calculator. I'm just going to plug in these values. I don't know them, so. I actually have to do your homework on the spot. So, forgive me. All right, for f of -1, I got 47. And the other one was 4, correct? Okay, and 4... This was -328. Right? So then what I end up seeing is f of -4 is the absolute minimum. This is the absolute maximum. And the endpoints end up being since they're not absolutes, what are the endpoints? They're nothing. Does that make sense?
No, can you explain that a little bit?
Yeah, so the endpoints end up being nothing because they cannot be relative, because relative means you can compare the left and the right hand side. Right? Remember, relative to its neighbors. Well, if it doesn't have a neighbor on the left or a neighbor on the right, how can you compare it?
So you're comparing them to the original values that you tested in the beginning, right?
Yeah, because see the endpoint's -2, right? So -2, anything beyond -2 won't work because it's the end. So how can you compare the -2 to some value to the left of it? You cannot. And by the same token, how can you compare something to the right of 5 if there's nothing there? You cannot. Does that make sense?
Yeah.
So the endpoints are either absolutes or nothing at all. Understood?
Yeah, I understand.
Okay, the next one was... oh, and someone wanted number 9 in this same section. So let me do number 9 in this same section. I hope that was clear. Did that answer your question? Yeah, okay, cool. Cool. Number 9 in the same section. We have 49 minus x squared in the interval from -7 to 0, and then 4x minus 1 from 0 to 7. It's a piecewise function for the function. And so what we want to check are endpoint values, right? So our endpoint values for this are -7 and 7, right? So let's do that first. So f of -7 tells us to plug into the first equation, correct? And so that's going to give us a 0. Does everyone understand that in terms of piecewise? Because I know sometimes that can be difficult for people. Okay. And then f of 7 tells us to plug in to the second, so that's going to be 27, right? Okay, and then let's take the derivative. So the derivative of the top is going to be a -2x, and the derivative of the bottom is going to be a 4, right? So the bottom one is not going to have, well, its lowest value there would be, we should check the 0 too, because that seems to be something important. That's going to give us a -1, correct? And the reason I have to check that value is because there's something critical happening there, right? Now, this one's going to have no issue. It's strictly increasing, right? This is what it's telling me. So it is strictly going to be increasing. This other one has something happen at 0, and when it's negative, it's positive, and when it's bigger than 0, it's negative. So that tells me that this looks like it's going to be a what? At 0, it could be some sort of potential maximum, right? We'll see though. So, and that's only based off of the top function, okay? So I want to show you. Do we have, let's look at the graph just so you guys can see. So from -7 to 0 is going to go a 0 value at 7 going this way with an open circle, correct? And then at -1, it's a closed circle, and it's going to be strictly increasing to, at 7, this value is going to be 27. Agree? This value here is 49. This is -1. So, based off of these things, do we have an absolute maximum?
No.
No, there is no absolute max. Do we have an absolute minimum?
-1.
That's correct, it's -1. Do we have a local maximum?
27.
No. Endpoints cannot be local.
Oh, that's right.
Do we have do we have a local minimum?
Yes, -1.
-1. Why can we check -1? because we can compare a value to the left. Right? Because if we look at like a negative 0.1, isn't that going to be something like 48 point something, something, something? So we do have a local there. Does that make sense?
Yeah.
Okay. Well, I can... That must be really close. I can hear the helicopters. Okay, the next question that I got, someone asked for number 11 on... Or number 7 on homework 11. So let me go to that. Yes. I thought I talked about that in class, but that's okay. Yeah. Now you have it, and that's the whole point, right? All right. Number 7 was the question, so let me get to number 7. No worries. I mean, it happens. It happened to all of us, right? It's your first time going through this. It makes sense that there are things that might be not totally clear the first time through, so no worries. All right, so let's look at this. It says consider the function below, and the function that I'm given is f of x is equal to x squared e to the negative x. And it says find the exact value of the minimum when x is greater than or equal to 0 for part A. So the minimum means I need to take the derivative, right? So the derivative would be 2x e to the negative x plus x squared negative e to the negative x, which is going to give me 2x e to the negative x minus x squared e to the negative x. And for x being greater than 0, so let's see if I can factor something out. This is going to be e to the negative x and 2x minus... I can pull out an x also. I'm trying to make my life as easy as possible. I'm going to get 2 minus x. So I can see that 0 is a critical number and 2 is a critical number, right? So 0 and 2. And I'm going to plug in values for this. So if I use 1, I'm going to get positive. I'm going to get a positive. If I use 2, anything greater than 2, I'm going to get a negative. Are we in agreement with that? Okay. So what we end up seeing is we need to plug in to our function and find out what these values are. So f of 0 plugged in is going to clearly give us 0, and f of 2 looks like it would be some sort of a max. What the heck is that? 2 squared times e to the negative 2. And I'm going to get 0.541, right? Okay, so it's asking for us in this problem for a maximum value or a minimum value. So our minimum value looks to be f of 0. Does that make sense? We okay?
Yes.
Okay, and then the maximum value, it says to find the max, well, I already have the derivative, I believe should be that 0.54. Let me just confirm. Yep. So this is our min. This is our min. This is our max. Okay? And then it says find the exact value at which f is increasing most rapidly. Okay? So to increase most rapidly, what should I do? We need to take the second derivative. And the reason we take the second derivative is to be able to find out where this is occurring as fast as possible. So what is the rate of the rate? So the second derivative is giving us the rate at how fast the rate is increasing. Terminology, right? Isn't it fun? So then the second derivative is going to be, we're going to use this guy to do it. Okay? So I'm going to get 2e to the negative x plus 2x negative e to the negative x minus 2x e to the negative x plus x squared e to the negative x. And then we need to solve, right? Well, something cool. We have something cool in this problem. We can pull out an e to the negative x. And we're going to end up with 2 plus x squared. I think I did that correct. Let's see. Oh, no, I didn't. I canceled when I should not have canceled. This piece, see that negative? That should make that a minus. So these are going to become a 4. So I'm going to get 2 minus 4x plus x squared. And then this piece here we'll be able to solve via the quadratic. So I'm going to get 4 plus minus the square root of 16 minus 4 times 2 times 1 all over 2, which is going to give me 2 plus minus the square root of 8 over 2, which should give me 2 plus minus root 2. Correct? So when we look at this, then the rate of the rate for, let me see what the problem asked again. It was asking, find the exact value at which it's increasing most rapidly. So if it's increasing most rapidly, it should correlate to something that is close to our maximum value, right? So our maximum value occurs at 2. So 2 minus root of 2 is still on the, it's on the increase. If we go with 2 plus radical 2, that's on the decrease. Does that make sense to everybody?
Yeah.
And since we're looking at the rate of increase, it has to be on this side. So it has to be the minus. That's the rate of increase. The denominator, or the 2 plus the root of x, is the fastest it is decreasing. The faster the decrease rate is decreasing, if that makes sense. What happened to the e? Oh, so I factored out the e. When is e ever 0? E to the negative x, or e to the x, is never 0 it just approaches 0, but it never gets to 0. So this will never be a 0 factor. This is the only piece that can get us to the 0, so that we can test the derivative. Does that make sense to everybody? Okay. Do you have any other questions for me? Well, I'd ask away.
I have a quick question on why it's 2 minus root 2 versus positive negative.
Sure.
Sorry.
So let's just look at the numbers as concrete so you can understand it that way, okay?
Okay.
So 2 to the 0.5 is so when we do the minus, that's this stupid thing. That's the same as 0.5857 blah blah blah, right? 2 plus root 2 is 3.41421. Okay? So if we're asking for the rate of increase, correct? Rate of increase, where is it increasing in our interval? From 0 to 2. It's decreasing from 2 on.
Oh, I see. Okay. So it would have to be less than 2. So you use the other one. Okay.
That's correct. That's why I did that.
Alright. Thank you.
Yep. Cool. I mean, it's my job to know how to explain it to you, right? So I've got to make it clear to you. So cool. All right. Number 2 on homework 11. All right. Let me see. Number 2. Okay. So number 2 has a graph, and then from that graph, okay, so I got to show you this picture because or else it's meaningless, right? So let me share this deal. All right, can you guys see the picture now? Can you see my mouse? Okay, so this first question's asking us, it's asking where is it increasing? So it's increasing from here to here, right? So from 0 to 1, it's increasing, and then it's increasing from what is that? 3 to 1, 2, 3, 4, 5, 6, 7. That looks like a 0 to me there. So to me, I think they're wrong. See how they have the answer here? I think it's from 3 to 5, and then from 5 to 7. This looks like a 0 right here. Let me see if I can. Yeah, I would argue that they're wrong. I'd go from 3 to 5 and then from 5 to 7 based off of, doesn't that look like a flat there? Like it's a 0? I mean, maybe it's not. Maybe it's a slight increase. But I could see where someone could go from 3 to 5 and then from 5 to 7. Okay, on the open interval, it's decreasing. So it's decreasing from 1 to 3. I agree with that. Concave up. So concavity is where it's turned. And so right here, it looks like it's from 2 to, I'd say 5. And then from 5 to 7. Oh, that's what they have. And then concave down, I would say that's from 0 to 2. And then from 5, from 3 to 4. Wait, 4 to 5. Does that make sense? It's this area right here. Can you guys see my mouse? I'm just, because I don't know if you can see my mouse or not, that'll bug me. Okay. The coordinates of the point of inflection. So the point of inflection is where it changes concavity. Okay. So the change in concavity for me is from concave down to concave up. Seems to happen right here at 2 comma. That's a -1. Is that? Oh no, that's 1. So 2. So I'd say 2, 2. Okay. And then where's the other point of inflection? It's going from concave up to concave down. Right here, it's changing concavity. So what is this? 1, 2, 3, 4. 4.3 or 4.28, whatever. Something close to that. Oh, I guess, yeah, it is just shy. 2.9, 2 point whatever. And then it changes concavity again right here. And that's at 5, let me see, 1, 2, 3, 4, 5. And then 1, 2, 3, 4. So at 5, 4. Does that make sense? That's where the concavity changes, where it's going from down to up, and then from up to down, and then from down to up. Trying to make sure the person who asked for the question isn't responding to me. Does that make sense to everyone else?
Oh, yes.
Okay. Is there any other questions you have for me? Or is it just you need to catch up on homework?
And sleep too.
Okay, there's some more homework and sleep too, yes. Okay, what's the other question? Okay, oh, homework 12, okay. Let me go back to my iPad. And then the question was homework 12, and I believe it was number 5. Let me see. Yeah, question 12, number 5. Let me do that. We'll go from there. Question number 5. Oh, okay. So in the problem that I have, it's telling me, it says you have a right cylinder inscribed in a cone with a height h and a base r. Find the largest possible volume. Okay, so in this is homework 12, number 5. So if we have a cone, right? In a circular cylinder, in a right circular cylinder, so no big deal. Something like this, correct? The problem tells us that we have a height of h and a radius of r. So no big deal. Let's do some. Oh, I actually drew it wrong. It says a right cylinder is inscribed in the cone, so it's reverse that. So I have a cone and then a cylinder that's within it, right? So some cylinder is hanging out inside of my cone. Ain't no thing. Okay, and the height of the cone was h, and the radius, I'll do it this way, is r. Okay? So if we call the radius of our cylinder x and we call its height we'll do this. We'll call this y. So then what ends up happening is, and I should do this in a different color so you guys don't get messed up. So this is my height from the top of the cylinder to the cone with the radius. And then this height here to the base is just going to be h minus y. Are we okay with that? Okay. So now what we want to do is we want to make some reference that's going to be beneficial to us in terms of this whole thing. So the ratio that we can do is we can think of it as some triangles, right? Some similar triangles. And so those similar triangles, we're going to say like this. This is x, this is y, this is h, this is r. Agreed? Well, yeah, I hope it's easier when I explain it because I'm supposed to make it clear for you, right? So now that I have these two right similar triangles, I can do ratios to these things, right? So I can say that y over x should equal h over r. Okay? And just to make my life easy, I'm going to say y is equal to hx over r, so that when I do this problem, I can do it in a way that's going to be beneficial for me. So one of the things that we need to know is the volume of our cylinder. So the volume of the cylinder is what? Do you guys remember volume of a cylinder? So I'll do the general. So volume of a cylinder is pi r squared h. Agreed? That's the general volume of a cylinder. Agreed? Okay. So then in our example, we're going to go volume is equal to pi. The radius of the cylinder is x. The height, so I'm going to have x squared. The height is going to be h minus y. Agreed? Okay. So let's see what we can do with that. So if I were to distribute this, couldn't I get pi x squared h minus pi x squared y? Yes?
Right.
But my y I know in terms of x and r. So I'm going to go pi x squared h minus pi x squared h x over r. Agreed?
Yes.
Okay. So this is the volume of our thing. And I'm going to clean it up just so it's pretty because I'm all about pretty. Okay, so now from here we can take the derivative of this and we're going to check for a maximum, right? So when we take the derivative, so v prime is going to be, with respect to x, is going to be 2x, 2 pi h x minus 3 pi h x squared all over r. Do we agree?
Why'd you make the x cubed?
Oh, because x squared times x.
Oh, okay. Yeah.
Okay. I can see I can factor out some things, so I can factor out pi I can factor out an h. I can factor out an x. So I'm going to get pi hx. So that's going to give me 2 minus 3 over rx. Correct? So I can see x is either 0 or x is equal to, what the heck's that going to be? 2r over 3. And clear as day, if the radius is 0, we have no maximum volume. So the maximum volume has to occur at 2r over 3. Does that make sense? Nicole wrote something. Let me see. 1/3 pi r2 is a cone, and for a cylinder, it's pi r squared h. Okay. Oh, yeah. Yeah. Okay. So if this is the max, then to find the volume, we need to substitute into our volume equation to find out what the volume is. I'll leave that to you. Okay? And what I mean by that is you would plug into, your x would go into this right here. Or in fact, let's do it all in terms of x. So before we take the derivative, I would plug it in here. So everything has, it's in terms of the x. Does that make sense? Okay, cool. Any other questions? Number 6 on the same section. Okay. The classic copper wire. Okay. So it says a piece of wire. This is number 6. I get so frustrated when I do that. Okay. It says a piece of wire is a 30 meter long wire is cut into 2 pieces. So we have some wire. It's 30 meters long. It's cut into 2 pieces. One piece is bent into a square, so we're going to have a square, and the other is put into a circle. So how much wire should be used for the square in order to maximize area? So the first one is max area. How much of the square should we have? Well, that is a common sense question there, but most people don't have that common sense. The maximum area that you can get, period, is a circle. So if you want to get the maximum area, you always want to have a circle. Well, no, I mean, there'll be some calculus involved in a second, but to maximize area is going to always be a circle. Always. So if you want to have the most surface, or if you want to have the most area in your home, make your home be a circle. For the amount of land that you have, that's going to get you the most area, right? Unless you have like some funky, like rectangular shaped property, then that changes things. But circles are most area when we don't have restrictions, okay? When we have fixed materials. Okay, so then the second part B, says how much wire should be used for the square in order to minimize the total area. Well, to minimize the total area, there's this balance, right? So let's just take our wire and let's say that we're going to cut it into two pieces, okay? So we'll call this side x. If this is x, then the total length, wouldn't that be 30 minus x? Does everyone agree with that? Okay, so then the area of this thing would be, for the square, wouldn't that be x divided by 4 squared, right? Because a square is going to have 4 equal sides, plus pi r squared. And so r squared, the circle is going to be 30 minus x over 2 pi squared. And I'm sure people are now tripping on how I got that. Are we okay with that? Sure. So, how do we get the... So if we have a circumference, right? Because we know the circumference is going to be 30 minus x, correct? So circumference is 2 pi r is 30 minus x. We want to find the radius, so that means r has to be 30 minus x over 2 pi. Does that make sense? Because the material to create that is going to be that wire piece turned into a circle. Okay? And so, trying to make my math look clean and pretty, I'm going to get pi 30 minus x squared over, actually I'm going to do this. Get rid of the pi. I'm going to get that right there. We also are in a closed interval here, right? That's important. How much wire do we have completely? 30 meters, correct? So the most that we can use is 30. The least that we can use is 0. So then from here, we should take the derivative to do our test. So I'm going to get 2x over 16 plus, I'm going to get 2 times 30 minus x times a negative 1 over 4 pi. So I'm going to get 2x, start cleaning it up a little bit. I'm going to get x over 8. That should now be a minus. 30 minus x over 2 pi. Do we agree? Okay, and then we want common denominators because we should have common denominators. It's kind of our thing. So I need pi up there, so that's going to be x pi over 8 pi minus, this one needs a 4. So I'm going to get, that's 120, and then minus 4 x. Does everyone agree with that? And then it's the numerator that matters for us. So I'm going to get x pi minus 120 plus 4x. We're going to see when that's equal to 0. Correct? And so from here, I'm going to get x pi plus 4 is equal to 120. So x is equal to 120 divided by pi over 4. And what the heck is that as a number? 120 divided by pi plus 4 is 16.803. So, again, the 16.803 is how much wire I should use for the square to minimize the area. So if I use a little bit more than half the wire, that will give me the minimum area possible. Does that make sense? Anything else? You guys need time to go do homework?
Yeah.
Well, if there's no more questions, I will definitely let you guys get caught up. And I also, please watch those videos from before. I think I did an okay job. I don't know. Please let me know if there are any questions on it. But I forget who finagled me into making the test on the 29th, but the test is going to be on the 29th. So kudos to that person. You should all be thanking that person.
You're welcome.
Yeah. We'll go into 4.9, which will be the last piece for the exam. Do I really? What do I teach like in those videos? That's funny. I'm curious to hear that. We'll go on to chapter 5 before the exam, but the test will only cover 4.1 through 4.5, 4.7, and 4.9. Okay. All right. It might be just because you got to remember too, when I taught the course, those videos, those were like the first videos we did when we first went into quarantine. So that might be true that I go into more detail now because of the whole quarantine thing. I've gotten used to you guys asking more questions and just trying to be more detail oriented for you guys. Maybe I become a softie. Who knows? But if it's beneficial for you, who cares, right? Well, okay. Then what I'll do here then is I'll let you guys go. I'll post up this recording for you all so you guys can have it, and then yeah, well, I'll see you guys on Tuesday. We'll do 4.9. If you have any need for homework extensions, please ask for them, and I'll do them. I'll hop on WebAssign right now to do those. So, like in the next 5 minutes, put in your homework extensions requests for homework you might need, so I can do that. Okay?
Thank you, Professor.
All right, my pleasure. You guys have a lovely weekend. We'll see you guys soon.
Thank you. Have a good weekend. Be safe.
You too.